Okay, all, thanks so much for sticking with us. Great to be back with everyone. Sorry, let me pause the music there. Great to be with everybody for our next session. Hopefully you're getting as much out of this day as we are and sticking with us for these fantastic sessions. So huge thank you to Trudy, Paul, Elliot, Brian, and Dean. Fantastic presentations. And welcome back. So our next session is a central heat pump water heater roundtable. Before introducing our moderators, let's do a quick word from our sponsors. The sponsor of this session is the California Energy Design Assistance Program. It's the only statewide utility incentive program for new construction and major renovations. CEDA promotes both electrification and decarbonization and works in collaborations with project teams to reduce energy demand, consumption, and carbon emissions. CEDA serves commercial, public, high-rise, multifamily, industrial, and agricultural projects in PG&E, SCE, SoCalGas, and San Diego Gas and Electric service areas. So here's a page to, if you're building in California, you should discuss your project with CEDA. Here is a page to do that. You can find the QR code link there. Reach out to Sean Williams or Tina Hendricks for information on incentives and design assistance through the CEDA program. So thank you so much to CEDA for sponsoring this Central Heat Pump Water Heater Roundtable. Okay, so now I want to introduce our next session for the Central Heat Pump Water Heater Roundtable and our panelists who will be on. We have Keshmira Engineer. She's the Emerging Technologies Program Manager at Bonneville Power Administration. She oversees a multi-million-dollar energy efficiency research portfolio and has been the leader of our commercial AWHI working group for going on 5 years now. And then joining Keshmira will be Helen Townsend. She's a senior project manager who manages electrification projects for DNR International with a focus on the Advanced Water Heating Initiative. And joining our moderators will be Albert Rooks from Small Planet Supply, Tim Totten from Lars, and Ann Yardley Caldwell from Elmco Stewart. So great to have you all with us. If you all wouldn't mind coming on camera, and we will get this party started. I think, is Keshmira having technical difficulties getting on?
I think Keshmira is here. I don't know if she can unmute herself, and I wanted to go ahead and share the screen. I just want to click my share button, but it says it's not allowing me right now.
Okay, I think I just stopped share, see if that lets you do it, Helen.
Thanks, Joe.
Yeah, there we are. As we're getting Keshmira's tech.
There we go.
Sort it out. Perfect. Thanks so much. Great to be with you all, and have a great session. Thanks.
Okay, great. Keshmira, are you there, or shall I take over for now? Okay, I think there's some technical issues getting started here, but thank you to everybody. Thanks, Joe, for the introduction, and thank you, CEDA, for sponsoring this session today. We are really excited to be part of Heat Pump Water Heater Day on representing the central heat pump water heater part. So a warm welcome to all of our panelists. We'll get to you just in a moment, but first of all, I'm Helen Townsend from DNR International. I support the Commercial Advanced Water Heating Initiative with Keshmira Keshmira Engineer, excuse me, who leads it up. I hope that she'll be able to join us momentarily here. So there are, this is just an exciting session today. We want to talk a little bit about where the market is for central heat pump water heater systems. We want to just dive into some of the the great applications and building types that are appropriate for central systems, some strategies for reducing costs and simplifying, reducing the risk, and especially some strategies for ensuring that we have successful installations that deliver and that persist after they're installed. So without further ado, let me ask the let's see, how about we start with you, Albert? Would you like to share your screen and introduce yourself? Albert Rooks from Small Planet Supply.
I would love to. Thank you very much. And you hear me, right?
Yes,
Okay.
I think you can just grab it. Let's see if I can stop sharing. I'll
Yeah,
stop sharing. There we go. Now you should be able to share, Albert.
great. Thank you. Okay, good. The funny thing is, I really uh, understand what Keshmira is going through trying to get a Zoom meeting to operate. Sometimes operating a Zoom meeting is actually harder than operating a central heat pump water heater once it's fully installed and up and running. So I thank you. My name is Albert Rooks. I'll switch into presenter mode there. Small Planet Supply water drop systems. And our company is really an end-to-end solution for central heat pump water heaters. We design, we help project teams size and develop projects. We work with a series of national distributors across the country with a growing market area. And our goal is really to be involved in the project from end to end. So end to end means starting with a engineering team, developing a project, seeing that all the way through sizing, consultation, delivery, and pricing and understanding site conditions with the contractor through tender, yeah, all the way through final delivery and startup. It's been really an interesting pathway developing these package skids. Our company and a great company called Steffes were really kind of the first in the market with these package skids. We're really happy with the way they come together and the way they operate, and happy to be here. And we've got just a lot of technology coming behind this because once we're able to set up an air source heat pump and lift cold water into hot, it then becomes, at least on our scale, all about energy management and interacting with renewable energy, interacting with utilities, and setting up systems where we can go into new construction and retrofit buildings and really fine tune the operation of the system by being able to reach into this high value asset, adjust set points, adjust programming to really maximize what we can get, how well we can get the system to operate. So, thanks.
Thank you, Albert. Tim, would you like to go ahead and introduce yourself from Lars and share your slides with us?
Do that. See if I can get out of my. There we go.
All right, hopefully everybody can see slide. My name is Tim Totten, Western Regional Sales Manager for Lars. And Lars is part of the Bradford White family. And that'll become relevant as we talk a little bit about, what we make. And we try to make a majority of our products in-house, made in U.S.
Tim, sorry to interrupt you. If you could make your slides like full size, it
Oh,
might be easier
sorry.
for us to see.
Let's try this. Oh, that didn't work. Oh, hold on. Sorry. Come on now.
That's it. Thank you.
It's hard to see on that way. Now, let's see if I can advance. You can see in the family, and this is just the Lars family, we make a lot of different water heaters. I've been selling water heaters for 30 years, everything from steam, instantaneous heaters to standard efficiency gas, condensing, water tube, fire tube, solar. I've been involved in pretty much all of them at one point or another. One thing that brought me to Lars, I did work for another CO2 heat pump manufacturer prior to working for Lars. And one of the reasons I came was this product you see here, this Lars Ether. And I think the big difference, and you see this in other energy sectors, or especially in the HVAC world, where Europe is kind of ahead of US took a long time for condensing products to catch up. And that's kind of where we are now. All the CO2 products you see in America, in North America right now, come from outside of North America. And there's nothing necessarily wrong with that. Every manufacturer purchases a certain amount of products, private labels from other people. Several of these products on the product family are purchased, private labeled with our strategic partners. But with CO2, especially, and heat pump, water heating in general, both being very new, it was critical, I think, that having a U.S. manufacturer putting in the R&D dollars and time to build and design something specifically for North America has tremendous importance. And some of that goes into little things like having a double wall heat exchanger, which European products don't. The other thing I wanted to show here is that we also make everything. So we make our own storage tanks. We make our own swing tanks. We have our own electric tankless water heaters. Those are all built in-house. So to build on what the previous presenter said, it is really all about systems. And when you get into these central plants, systems become very important, and there's a lot more I's to be dotted and T's to be crossed. So I think that'll be some really good conversation in the rest of this. And I think I'll wrap it up for me.
Great. Thank you, Tim. And I see we have Keshmira with us now as well. Great to have you, Keshmira. Can you hear us okay?
I can hear you fine. Can you hear me?
Yes. Yes.
Thank
All's good now. Awesome. So let's, Anne, would you like to introduce yourself and share your slides now?
Yes. Good morning, or good afternoon. I'm on the East Coast today. Trying to find my slide. There it is. Can you see the slide okay?
Not quite yet. You may have to click the share button twice.
Oh, you know what? Hang on one sec. I only did it once. Huh. Well, it's not letting me share the screen, so no worries. Mine's just about our company. So I'm Ann Yardley, and I'm with Elmco Stewart. We're a manufacturer's rep in Southern California. So we represent Colmac heat pumps. And along with the heat pumps, we also manufacture, I'm under Morris Group International, and we manufacture about 27 different divisions of basically plumbing products, one of which is a thermostatic mixing valve. And the gentleman behind that has about 43 patents, and he's brilliant. And we can tie it into the BMS, and we can run reports. And I know there was a lot of discussion about the mixing valves, and it's pretty incredible what he's done. I love ours just because it's because of his mastermind behind it. So we do also, when he was saying, Albert, I think you were saying from beginning to end, we call it cradle to grave. So with our heat pumps, we can do them simple. We can design them with storage tanks, swing tanks, mixing valves. We can put whatever you want in there. But the main thing is we'd like to have all of us successful, not only Colmac, we want Nile, we want all the other manufacturers on here, Lars, A.O. Smith. If we're all successful, then it gives heat pumps a better opportunity to be used in any capacity. I only do commercial buildings, large commercial buildings, but I was really interested in the last panel on home builders. I found that fascinating because I just don't get involved with that. The other thing that we do is on the job sites, we are there from beginning to end because these contractors are not familiar with installation so much. So we try and be extremely supportive from the second they get that job all the way to the end. And then we'll do owners training to the owners at the final stage and make sure we're available.
That's great. Thanks, Anne. And we did end up seeing your slide in the end. It just took a little while to load.
Oh,
so
it's probably like me, a little slow on the take.
We're all in this together. We can't get it. We can't mess it up. I want to give Keshmira a chance just to introduce herself for those of you who don't already know her. Go ahead, Keshmira.
Oh, so sorry. I am joining late. Also had some uptake issues, and so I'm right there with you today. My name is Keshmira, and I work at Bonneville Power Administration. I'm the program manager for our emerging technologies office, and I'm also very fortunate to be leading the commercial initiative for central heat pump water heaters at AWHI. So thank you.
Okay, I'm going to share my screen again, and we're going to start to move into our discussion section here. Let's hopefully this will load up okay. So, we have such great panelists here. We have a lot of expertise and information there. So I've put together some questions which we can stick to, we can deviate from. This is not a fixed agenda, but we'd like to at least touch on these topics. There is a chat feature that anybody can put a question into. I'm not sure I'll be able to see it as I'm sharing my screen, but hopefully you all will see those chats pop up. So we're going to start just directing the questions, but panelists, speak up. This is your area. If you want to contribute to any particular question, please do. So I wanted to just start with talking about applications. Which applications are central heat pump water heaters suited to? We know about multifamily. We know there's other applications as well. Kind of interested in how. Well, let's just maybe start with Tim on this one. So, from your perspective, Tim, what are good applications? What are good building types for central heat pump water heaters?
Well, on the West Coast and where, I think both the coasts where heat pumps are gaining the most purchase, what applications everybody's really focused on multifamily. And that is important because that is, from a numbers standpoint, and government spending dollars will be there. But we're seeing a lot of other areas where we start to branch off, starting to see more industrial applications, wineries, food processing, seeing some of those. So, I would say really the thing that probably dictates the most whether heat pumps going to be appropriate. New construction in some areas that's legislated. We kind of know, hey, it's not going to be gas, it's not going to be electric resistance. But retrofits, I think, are the area where the industry is going to be struggling the most. Because as the industry has gone from 50 years ago, water heating was big tanks with a steam coil in it, and you make hot water, and then they moved the other direction to no storage and little instantaneous units. But when we're doing retrofit applications, it becomes tough when we're talking about 3,000 or 4,000 gallons of storage. The weight and physical space to put those in retrofits is becoming a major issue. So I think when we're looking at applications, size obviously it has to be a significant load to be a central plant. But then the other thing that a lot of people aren't thinking about, because it's so different, is the size, weight, and where we're going to put this equipment in a retrofit. That's where prepackaging, I think, becomes even more critical.
Yeah, I wonder, Albert, if you have anything to add to that in terms of applications that you've been thinking about.
Yeah, I do. We really design around multifamily, and because we're really working with the CO2 product exclusively, that's a product, that's a refrigerant and a product that's really well suited for large dump loads. Not a great product, at least in my opinion, for maybe commercial applications where there's a lot of recirc loss. We need a lot of usage, and then our product in CO2 is well suited for that. I think, the other interesting applications about large loads in commercial and industrial is really interesting. Somebody got funded with a new product for a dairy that'll be going in, and we'll see how that works. And lots of really good large loads there. So I think, the other thing, as we deploy these across, loads that have regular usage and usage that we can kind of plan around allows us to apply more grid flexibility, look at storage, looking at storage as maybe thermal batteries, taking the best advantage of working around peak utility rates. And really kind of where I want to go is what's coming to us here, probably not very far, is more dynamic pricing from utilities, right? So there's a couple of national labs working on dynamic price profiles. We can match those up with storage and really understand usage. And then we start getting into something a little farther along the trail than taking items and lifting cold water to hot. We're really starting to head in that real energy management area to a much higher degree than even we thought of, 5 years ago. So we stay focused on some of these applications, and we look for really good opportunities to develop technology to leverage our energy inputs and reduce our connected load. So I'm going to turn it over. Otherwise, I'll keep going.
I was wondering maybe, Anne, if you want to talk to us a little bit about the market support and equipment performance, system performance that you know.
So on our units, we have them from 5 horsepower up to 30 horsepower, and we use different refrigerants. So we have R134 up to 513A. So it is based differently. They have different performance factors on each unit, and it depends on the climate. So we have some up in very cold climates and some in warm. When it's in the warmer climate, it's going to have much higher performance rates, and depending on the time of year. We do have a system that will actually sees the performance of each unit, and then we can run reports. And that's helping with the owners, helping with looking at the COPs and making sure that we're getting the best system for our clients. So it's something that, and it keeps improving every day, not only for us, I think for all of us. The technology keeps getting better and better every day.
Thanks, Anne. We do have a few questions in the chat that I think are pretty interesting, and I can see them, so I'm happy to work that piece of it, Helen.
Yep.
But we do have a question that's like, are the appropriate multifamily locations limited to more than 5 units, or can heat pump water heaters be used in smaller buildings as well? Does one of you want to take that question?
I'll answer that. That's very equipment and manufacturer specific, obviously. For us, we started at the kind of large end of things. So for our products, typically we're looking at 150 apartments before it starts to fit into our wheelhouse or our current offering.
Anyone else?
Yeah, I think it's complicated, but it's not complicated. When you get into smaller buildings, then you get into what the actual energy source is, right? If it's an air source heat pump, where are we placing it? Where is it drawing its input energy? How big the load is? And then you're just starting to wonder about, if we're using more of a unitary design, can we fit it in the building? Is there enough volume of air source in the building to operate it? But certainly you can work with very, very small buildings. I think the smallest buildings that we're in right now is a California tech project that we did a few years ago with, I want to say, 8 apartments in maybe a little bit higher occupancy rates. But looking at that, maybe that's kind of the smaller size of our equipment, but we know other manufacturers on the market make really good, unitary 160, 180, 200 gallon systems. And then it's just about where we can put them. And because those sizes can probably meet some really small, 2, 3, 5 unit buildings.
Thank you. Thank you. And Helen, I'll ask the next question if that's all right. Maybe Tim, you can talk about the delivery approach? Like, how long does it take to get one of these delivered to the site? What kind of, how much planning needs to be happening in advance, and who needs to be thinking about those orders?
That's a great question. A lot better now than it was, during COVID, where everybody's supply chains were destroyed, and products that used to be, 4 or 5 weeks turned into 50 weeks. So I think most people have maybe not fully recovered, but are much better. So I think in the delivery, again, we're covering a wide spectrum of product offerings, right? So unitary units, are generally going to be in stock at a distributor locally. But when you look at what I'll say a larger commercial central plant, lead times can really go into that. I mean, for us right now, it's about 10 to 12 weeks. But again, that's a part where I think the more control you can exert over your supply chain is important. So, we've acquired several companies that were in our supply chain to come in under our family. So, these larger products, there is a potential for long lead times. There are definitely more I's to be dotted and T's to be crossed. And I'm going to just dive into just sizing a little bit here, because that's kind of part of the delivery. And, I size 2-3 heat pump central plants a week. And the range of sizing, it's not that a manufacturer doesn't know what his equipment will do, but I'll get engineers say, hey, this guy quoted me this, and I feel it's too small. And this guy quoted me that one, it's way too big. And of course, I will make a selection in that Goldilocks in the middle where you want it. But you see people just generically saying, hey, well, 15 gallons per day per person, all the way up to 30 gallons per day per person, both for multifamily. And I think a topic here it comes up with that drastic oversizing with gas-fired equipment. That never really mattered that much, right? Typical gas-fired equipment, I oversized by 50%. It cost me another, on a central plant, it cost me another $20,000. Now, when we go to heat pump, and specifically, for us, CO2 heat pump, which is generally a more premium product, when we oversize a project, it might cost $200,000 more. So oversizing and understanding and having strategies to mitigate, instead of just blindly oversizing everything, which just kills a lot of projects, right? People see them and go, I can't spend $300,000 on something I would have done last year for $30,000. So I think that there's just a lot of ways of how we attack it. And I'm a big proponent of, if the local legislation allows it to, really kind of max out that heat pump. And then that extra 10 or 20 or 30% that we need on the coldest day, let's make that up with electric resistance if we can, or anything. It really helps keep the cost in place. And, we're not at a point yet in this industry where, we've got good rules of thumb and everybody's kind of like, oh yeah, this is what we do. And so there's a lot of, that's what they're doing. And compared to us, we adjust, we tweak. So it's, like I said, I think I'll just wrap that up and just say there's so many more I's to be dotted and T's to be crossed with heat pump water heating, that, if you pick a vendor, follow them beginning to end, I guess is what I say. You got to commit one way or the other. Because if you try to buy a heat pump from one guy and save 2 nickels and buy tanks from somebody else and pumps are, that's how things go wrong in a hurry.
I think that really, Tim, leads right into the question of how is it delivered? What is the approach to delivery? Are we, getting the parts and pieces from different people? Is there one source with one warranty?
Well,
is everything delivered specified?
I think that's where, again, the wide spectrum. So, when you look at our heat pump, it's, 8 foot by 8 foot by 4 foot and weighs 2,500 pounds. And then we attach a couple thousand gallon tanks to that. All of a sudden, there's that crossover where how feasible is it to now get, if I'm putting this in a high rise downtown and I need to get a crane that can, lift 20,000 pounds versus 10, or size or freight, all those things work in. So I think that you're in that where if you want a complete system, when you get so big, it's hard to package. But I think on the smaller applications, packaging has a lot of benefit. And I think that that's the way the industry will have to go eventually. And I think packaging also needs to get probably beyond the taking just the components that we have off the shelf and pre-piping them in a different way. I think there's a lot of room in the future for manufacturers to do a better job of integrating the actual design instead of just putting pieces together inside a box, which is way better than doing it in the field. But I think there's some runway for manufacturers to create a better mousetrap in a prepackaged unit outside of the kind of unitary designs we have now.
Thanks a lot. Albert, do you want to talk a little bit about delivery too in your product?
Yeah, sure. Be happy to. So when I think about delivery and lead times, I mean, it's an interesting period right now. There's a lot of conversion. And as we move more into heat pumps, especially in larger buildings, we need more storage. And as we move into more grid flexibility, we need even more storage. So I'm noticing this happens with some irregularity. Tank lead times can be a bit unstable, right? The market kind of pops up and down. We try to work with some really tight lead times. We do get challenged with that. We're actually going to try, because we're a small producer, we've got a smaller production chain to manage, right? So we're trying a new approach in offering our distributors ready dates, so that we can take an approach of saying, sure, we're trying to maintain a 10 to 12 week lead time, but as the market transitions to more and more heat pumps, it really does become kind of a challenge, no matter what scale you are, to match that production capacity with increased demand. So one of the things we're going to try and do is to really extend a hand to distributors and teams putting together a project saying, hey, we know you can't give us a PO to say, hey, give me a water heater, right? Because we got to go through submittals, we got to go through tender. There's a lot of steps, and sometimes those bump right up against a production minimum, assuming there's capacity. So what we're trying to do is say, okay, if you can forecast out 6 months and you think the site's going to be ready, we'll reserve a production date. We'll back the production date up, and apply it to products and what the production requirements are. And so we'll be able to work with our customers and our distributors to kind of flatten out the time, make it a little more reliable, and see if we can make the success a little more incremental and a little less risk. Because frankly, it can be a bit challenging at times, especially when you're in a system. If you're just a heat pump, you only have responsibility of a single appliance or a single box, or maybe a few of them. But if you're offering a full system, whether it's off-the-shelf components or not, there's a certain supply chain dynamic that is going to come up and really announce itself to us over the next 2 to 5 years. So sorry, I think part of your question, Keshmira, was also in skid, fully specified, custom, and so forth. And we really embrace the skid idea. We recognize that we might be in that future a little bit early, and people have to kind of catch up. It's crazy things like, there are architects in the world they're not really considering the domestic hot water plant, and they're designing a mechanical room. And that's not really how you approach a building with a package, right? There's a whole market transition that has to happen with packages. And it really starts with schematic design and thinking about what the equipment is, how big it is, and where it's going to be placed. Then you can kind of get into delivery systems, because once the building's massed, it's, you're really kind of locked into things, and you're really kind of playing the same game you're playing with retrofits, which is also a challenge because it's really about space, and understanding what resources and trying to get ahead and make some key decisions before it goes out to a mechanical engineer to kind of give them room to devise the best system.
I think Anne, it was you saying when in the introduction about communication with building owners is important, communication with installers is important, the communication, the training, the support. Can you speak a little bit to the role that role in just bringing people along, making sure they have information that they need?
So it's been a long process. We started out with only the manufacturers, only Colmac would come out and do our trainings and all our installations. And it got tricky because they're far away. So not only were we having the long lead times like everyone else during COVID, it was hard to get anyone here to even install or do retrofit or new construction, anything. It was very, very difficult. But now we just brought on board another company recently called MCore, which probably everyone's familiar with. They are national. They have done a tremendous job helping us with owner training, with installation. They're, refrigeration technicians. They're also regular technicians, and they have a very educated group, and they're very familiar with heat pumps. So that's been very helpful for us, because I'm telling you, 2 years ago, it was extremely difficult, and it made it tough on all the projects. But now we're at the point where I feel like we're ready to go on any kind of project. Like you were saying, the small pumps, we can go from, the small 5 horsepower, 1 pump system to over 200 pumps on a very large system. And we can actually take that, we can manage it, we can install it, and we can maintain it. So we've come a long way, but it hasn't been easy, I can tell you that.
That's great. I do have a question coming out of the chat, and I'm hopefully reading it correctly. And I'll leave it up to you guys to decide who goes first. Are the heat pump water heater models available, or when will they be available to address the new refrigerant transitions? So are products available?
For our products, we're there. We started with that premise, and there's all these questions about some of the new refrigerants have PFAS and some don't, and some have higher pressures and have more challenges. And yeah, we use some prepackaged equipment that we're able to jump ahead of those challenges. I kind of really like what I believe Tim was talking about in maybe rethinking and repositioning the packaged units into more of an integrated, larger central plant, and doing that, and all that development happening with kind of the newer style refrigerants. There's it's kind of, there's a long runway out there. So we made that choice deliberately to get into the newest, cleanest refrigerant possible.
Thank you. Anne or Tim, any thoughts on that?
Yeah, I can tell you what we have available. I think I mentioned at the beginning, we go from 134A up to 513. So we have a wide range. It's been hard to get all those refrigerants tested. The CO2, they've done a great job. We've had a harder time getting everything tested by all the correct agencies and meeting the envelope on the 513 and the 410. But we do have them available, and they're a little bit longer lead times. We're probably looking at 18 to 20 weeks for those larger units in that refrigerant. But the smaller units with 134, usually I have in stock. So it just depends on the application for us.
I'd like to speak to, like Water Drop, we are a CO2 product. We believe that's the end. And I guess we'll get on a soapbox here for a second. When we're talking about, hey, we're transforming the industry, heat pumps, if you ask the core question of why are we going from heat pumps away from gas and resistance? And, there's two answers to that, right? Emissions locally, and then, climate change. What is the effect? And in probably on this call, there's probably the whole spectrum of true believers that, hey, this is an existential threat to the, humankind, and we need to do a better job. Or, there'll be people on this call that are like, well, that's what's be regulated, and that's, what we'll do. And so if you're on the side of, hey, we're doing this to make the planet greener, it's really hard to go with even a synthetic refrigerant, period. I'll be honest. When you look at GWP, and that's a term we use all the time, global warming potential. And when people say that, they're talking about GWP 100, and that's the effect that refrigerant is going to have over 100 years. And 100 years is a long time. So if you're thinking that, hey, this is a little more urgent than that, then we shouldn't be looking at GWP 100. We should be looking at GWP 20, which is the effect that it has in 20 years and not 100 years. And I think that's a much more appropriate timeline to the people on this call. The thing that comes up is you will see, you might have a refrigerant, say R32, it's 700 something for 100 for their GWP. But in 20 years, their 20-year GWP is like 2,500. And even at 700, it's kind of like if you have two young engineers and one engineer specifies a synthetic refrigerant and one spends CO2, well, the one that spent CO2 is going to have to spend the rest of their career, every job they do for the rest of their career, to do CO2 to make up for she has to specify 700 more CO2 jobs to make up for that one, synthetic. So if we're not all, going in the same direction, it's hard. So I think that you're going to see some advances. Propane's making a big push in Europe. We're not seeing that here because of NFPA. Ammonia. These are all old school, our great-great-grandfather refrigerants. And I think there's a place. You're always going to have a good, better, best. And certainly synthetic refrigerants cost less, and for bang for the buck in warmer climates, it makes sense. But I think CO2 is the future, and we've gone through cycles in refrigerants of outlining, oh, those are really bad. Oh, no, those are bad. And no, those are bad. But these half steps, we're just going to have another one in 10 or 15 years where some of these low, quote, low GWP refrigerants are going to, I think, get sidelined. So I'd rather the industry put all their effort into making the best products from the get-go early on, and get the volume to make that more attractive financially than it is currently.
Yeah, thanks, Tim. We've had a question in the chat here, which I can now see. I figured out how to do that. I don't use Zoom all that often. I'm usually a Teams person, but can the panel talk about suggestions they have to educate or engage the market, especially via local ASPE chapter meetings?
So I know personally, I've done, I think, 3 just in Southern California, in Los Angeles, Orange County, and San Diego. We've educated all 3 ASPE chapters as well as so as the other manufacturers. I know we've done a really good job actually on that part. We just had a heat pump water heat day in Orange County and had over, I think, 75 engineers. Very successful. All the manufacturers were there. We had panelists. There were a couple from Ecotope that flew in, gentleman from back east. One of the engineers back there, I can't remember his name. He was fantastic. And it was a good session from 7 to 4. And it was a really well thought out educational day. I think where we have more of a problem is with the contractors and the installers. And that's where it would be nice if we had something that was more consistent and we all agreed on nationally and locally on how to get that done. But it's expensive and everyone learns differently. So I know we're all looking at how we can actually educate everyone.
Yeah.
Seems like, I'll just chime in. It just seems like a very appropriate question for conference week and for ASPE conference week. And well, the education is kind of endless, right? It's just in some trades, I think, in personal services, it's always be marketing, right? Always, 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 always. In education for the next runway, we are always going to be educating. And we've worked in many, many educational efforts, including with DNR Learn and our own individual webinars, our in-person events, and then with our distributors also. The nice spot is that's kind of a little bit of the funnest work is you get to meet people at a skill level or an understanding level and work with them to develop new skills and new understandings. And just in human-to-human contact, it's a really nice place to be. So again, one of those things in life that's easier than figuring out how to get into this Zoom meeting and share your screen.
Indeed. I'm curious, we talk a lot about training for contractors and installers, but once these systems are in, they need to be maintained. They need the operations folks, the maintenance folks need to understand and keep these things running so that they're delivering the efficiencies and the performance that we expect. So just curious a little bit, of course, there are always lessons learned. A lot of these technologies are, as they're emerging, we find we put them into sites and something goes wrong that we didn't anticipate. And then we go back and correct it. And then something else goes wrong. And so I'm a little curious, it's kind of a broad question, but some lessons learned that would factor into trainings for the future.
Well, I know I just spoke. I'll make this really quick. We learned the hard way. We spent years doing site-built systems and finding every deviation possible in the process of planning to installation and startup. And so it's making it as unitary as possible, be it a skid or a site-built system, is great. But the recent change that we made is we built in full connectivity. And so any product that leaves our door right now has a connection with our engineering desk. And we're looking at heat pump, leaving water temperature, ambient temperature, multiple thermistors on the storage so that we can see how things are working. Even things like water pressure. We recently had a building that had a big pressure spike, and that created an issue. And we'd like to be able to see that actually and record that in time associated with that piece of equipment. So building in connectivity to help those people maintain the system, because it's, sometimes those people turn over and there's another set of education that has to be done. So finding additional ways to stay connected with that equipment is probably helpful for everybody.
Yeah, I think if you don't mind, I'll pop in. I think Albert spot on. Everything's more connected. Whether it's utilized or not, is a totally different story. and we know CTA 2045 is the utility protocol to keep in contact. Yet I mean, there's a lot of equipment out there that utilizes that as a way to keep contact, at least with the utility. We're not really seeing that implemented much. And really, I think one of the big things we see, the difference between multifamily and a central plan and a different commercial application is the amount of connectivity and also the local maintenance ability resources, right? So if you're at a college university doing a central plant, you've got generally, well-funded, capable maintenance staff. Multifamily, generally the abilities of that maintenance staff is considerably less. So it's incredibly important that we make these systems are very complex, but that we make them easy to navigate, to understand. And that's the manufacturer's job, to take all the complexity and make it like an iPhone, right? You get a brand new iPhone, you don't even have to read the instructions. You just start working on it. I would say the entire industry is pretty far away from that point, but I think that's where we're going to have to get to get some better adoption on this.
I was just going to throw in the nice part about our system, and I think all of ours, is once it's installed, and that's the tricky part, and set up, there's really not much maintenance. We have to change an air filter and flush it every couple of years, depending on the water quality. So they're easier, I think, to maintain than other products. Ours, we have a LED screen with icons. It's very simple to see if there's something wrong. It's very easy to correct and maintain. So as far as that goes, I think it's simpler. I agree with Tim though. When you're multifamily, I tend to refer maintenance companies to them. I don't think they don't understand the product. They still think it's a boiler. But if you're on a university or hospital or larger project, we can actually train them and get them up to speed.
Yeah, agreed. I think, those are really good points. The connectivity is also helpful in those multifamily, so that it makes that communication about all the components, right? It's not just one of the components, it's the whole system. So having eyes on and the ability to diagnose what's going on at all the data points in the whole system is great. And AWHI's got, kind of another channel with the load connectability that Noah and Jeff Wicks run, and they produced they had a presenter come on from the southern central part of the U.S. that ran a study of demand response, grid flexibility, riding on individual Wi-Fi networks at the building, and that was real. That's an issue that we want to recognize, is that we probably don't want to ride on user Wi-Fi. So fortunately, in the higher value assets, we can put in its own cell or LTE signal that's independent of all the other networks and is always available, so that if something needs to be diagnosed and somebody needs to service it, we've got eyes on, and we can fix it quickly and keep going, because things do happen. And the best, and kind of all this my interpretation of all this work of this organization and other organizations is to deliver the highest customer satisfaction, and the customer is the user, the occupant, right? So less downtime, higher reliability will get us to full adoption rates faster and more effectively.
Well, that's a perfect segue, Albert, into our final 5 minutes of our conversation here today. So I guess I'd like to ask each of you to think about what you think the next year, the next horizon, the next 18 months, what do you think we need to transform this market even further?
Utility incentives.
I'd say better understanding or standardization on sizing.
Of sizing, did you say?
Yes.
Mm-hmm.
I think, again, I think oversizing kills a lot of projects from a cost standpoint.
I agree with both of those. I just we're doing so many projects per day. I don't even know what 18 months out looks like because we're so busy in just day to day. I can only see it growing, and where I am, it's highly incentivized, and there's a lot of buy-in. So I'm in a lucky area where this is just it's crazy busy. That's a good thing. We're happy about that.
Well, since you guys answered so quickly, I'm going to throw one more out there. So what to you makes a really successful project? Name 2 characteristics or 1.
For me, it's have a good engineer that does a great design, contractor, unfortunately where we are, probably a union contractor who can install it and make sure the system works, and then have an owner that's happy at the end with high COPs and efficiencies.
Anyone else?
For me, coordination. The more we can have coordination on these larger plants where we have a lot, we've got a lot of stakeholders. I think it just takes a lot more diligence than an old school gas-fired plant, and people got to get used to spending that extra time dotting those I's and crossing those T's, and us making sure that they understand what I's need to be dotted and T's need to be crossed. So I think just evolution and communication would be great.
Yeah, I'll just chime in with a flexible and interested, engaged team. Everyone, especially the installing contractor.
Great. Well, thank you, everyone, for your time today. It's a really amazing panel. Clearly, we have our market transformers right here sharing their expertise with us. And so I'm glad that you guys could join us and grateful for your input.
Yeah, and thank you to everybody for just participating in today's Heat Pump Water Heater Day. We want to also thank the session sponsor, CETA, of course, all our wonderful panelists for all the great work you're doing. We really appreciate you.
Thank you, guys. We appreciate it. Happy Water Heat Pump Day.
Thanks so much, man. Thanks, Keshmira. Thanks, Tim. Thanks, Albert. Thanks, Helen, for a fantastic session. Wow, I love that idea. Let's make central heat pump water heaters like iPhones. Thank you for that. Yes, so huge thanks for sticking with us for the central heat pump water heater session in our program. We are now going to take a 5-minute break. Don't go anywhere, though, because we've got the Excellence in Water Heating Awards up next at 12:35 Pacific, 3:35 Eastern. So we'll see you there. And one last reminder, keep posting online. Let's break the internet with our messages about heat pump water heaters. Keep posting. All right. Thanks so much. We'll see you in 5.